Good morning, good afternoon, wherever you are joining us from, and welcome to this, our final winter webinar roundup of 2024. I'm Francis Fisher, as always, and I am joined today by four of my colleagues from Weidmann around the world. I have Balz Schlittler and Lukas Hauser in Rapperswil, Switzerland, and I have Brad Greaves and Jason Beaudoin, a couple of familiar faces there from our St. Johnsbury, Vermont, USA site with us. So this webinar, we are thinking of doing something a little bit different. So as many of you have joined us for the live panel discussions over the last 12 months, there were many questions that we didn't get the opportunity to answer. We tried to reach out to as many of you as possible, but sometimes that proved to be more of a challenge than we expected. So I have all of your questions here from the previous webinars that we didn't get a chance to answer that we can try and get to today. So how will the format work today? Well, first of all, we will give a quick 2-slide preview or review, should I say, of the previous webinars, just so that you can all remember what we've covered in the past. And then from there, we encourage a live panel discussion for around 30 to 40 minutes, where you can put your questions in the question box. So here, thank you, Jason, is the how to ask a question, which you've seen before. And I will then try to get to your live questions as well as some of the questions that we didn't answer previously. So with that, I'm going to hand over to Jason, who will give you a preview of or a review, sorry, of the early webinar we did this year, and hopefully Lukas Hauser will not be the disappearing man for the rest of the webinar. So over to you, Jason, and please, as I say, you can type your questions anytime you'd like into the box. I will get them, and I promise I will try and get them answered for you in the second half of the webinar. So Jason, over to you, and I'll see you on the other side. Thank you.
Thank you, Frankie. So I'll just highlight again here what Frankie had said to everybody. You can ask questions at any time. We do have a bit of a queue that were from previous webinars, but we encourage new questions as well. So feel free to send them in. And what I'm going to do is first cover the one we did in the spring of 2024 called Insulation Design Concepts. This covered a lot of topics, and I will encourage you to please go back to, if you're curious or missed that one, go back and please rewatch that webinar. The links will be shared afterwards, later on here, in fact, I believe. But go ahead and review those because there's a lot here that I'm going to try to compress into 2 slides. So some of the things that we covered were mechanical properties and how to optimize short circuit resilience through proper coil sizing, using appropriate materials, understanding the mechanical properties of the transformer board from a compressibility and reverse compressibility for sizing, for axial forces, and your short circuit withstand strength. Again, through use of the appropriate insulation materials in the appropriate places. And to do that best, you need to understand what the properties are. What you're seeing here in these images, and I hope that my mouse is showing up a little bit anyways. I don't want to go to the laser pointer. Key spacers, this is just the axial forces we're looking at right now. There's other material optimization forces that are considerations that are not shown on this slide, but are covered in detail in the previous webinar, including what the conductor wrap properties may be, how to best utilize and understand those. Next, some of the other things that we looked at were understanding dielectric stress distribution. And we started at a very fundamental level, and we got into some basic calculations to show you what the different material properties were and how they affected your dielectric designs. And then referencing ultimately back to appropriate use of the Weidmann reference curves. Now, Brad?
Great, thank you, Jason. So looking back at a previous webinar again, we talked about the accelerated aging test and ultimately the determination of the transformer board thermal class. So if you could go to the next slide, Jason. So first, in this webinar, we talked about some of the industry practices and industry standards that are out there when we talk about board or insulating system thermal classes. And ultimately, we said that there are industry practices that recognize the utilization of non-thermally upgraded pressboard or standard pressboard with the use of thermally upgraded paper in mineral oil as a 120 class insulation system. And then we talked about the how do we test that, and using the IEEE C57-100 test method that really describes and gives guidance on how to do this evaluation, specifically looking at the sealed tube accelerated aging test. And within this test method, we look at table for the sealed tube material ratios in this standard, table B1. And we see we have two different material ratios that we utilize, both really depending on where the insulation system will be used, whether it's power or distribution. So in our test program, we did both systems, the power system where we used high density press board or T4 and thermally upgraded Kraft or TUK. And then also we tested the distribution ratio where we were using a lower medium density board, high val, and TUK. Going through the standard, we tested all three temperatures with multiple aging periods per temperature. And we can see in the bottom right a graph of all three temperatures represented, 150, 165, and 180. And each point showing the tensile strength retention at that temperature at different times, different aging periods throughout the periods of this test. And in our system, we had used the candidate or the transformer board as the candidate system. Go ahead to the next slide, Jason. So going into this test study, and really what we were trying to determine, our problem statement was, can we determine the thermal class of transformer board using an industry recognized test procedure? Again, this IEEE C57-100. And what we determined was yes. By following these steps, we were able to confirm that pressboard, standard pressboard, when used in conjunction with thermally upgraded Kraft paper in mineral oil, has a class of 120. You can see in the right-hand side the life curve. Just picking one, this was the high val in the distribution transformer ratio. We can see the life curve, and then in the bottom right, showing we used three different methods to make this confirmation of the thermal class. If you're interested in those in detail, please again go back and watch that previous webinar. But just showing that, looking at it various ways, we can confirm that, again, thermally upgraded Kraft paper with non-thermally upgraded transformer board in mineral oil is a class of 120. Thank you. And with this, I believe I'll hand it back over to Jason.
Yep. Thank you, Brad. All right. So one of the other webinars that we did is what we called Optimize Insulation for Renewable Energy Transformers. As we're all aware, renewable energy is a very hot button topic. It's growing. It's a necessary new part of our global energy strategy across the world, obviously global. Here's a few things we pulled from here. You can see the projected growth. Actually, at this point, it's not projected. It is growth, and it's going to continue to grow. If you all recall seeing these graphs over time, it gets more and more renewables, largely wind and solar. Not necessarily a ton of other renewables, but you'll see hydros quite a bit in here as well. These are all growing, and it has a major effect, can have a major effect, I should say, on what the load profile is and how best to utilize that and really to deal with it. In each of these lines, 1, 2, 3, and 4 correlate with the bullet points over here. So it's intermittent variable character, the unutilized excessive transformer capacity, i.e., is there a peak capacity that's still available that isn't being used? Different sites with different ambient temperatures, so your transformer could age quicker. based on what the load profile is, whether it's a hotter ambient temperature or it's a greater load capacity required for that region, or just line 4 here, this little one down on the bottom, although you can see that the graphs, the dotted lines, these 3 and 4 are not, they're juxtaposed and need to be corrected. You can see that there's different, what we call not clean power, I guess. There's a number of things that are coming in globally that are going to affect the renewable market and how it plays into power quality, the number of transformers that are out there, power availability, including the European Union Green Deal to sustainable peak load solution. The US has put another large one in place just recently that wasn't part of this presentation. And again, I encourage you to go back and re-watch these other webinars we did, because they get into a lot more of these details. This is a condensed version, what we're showing here. It's 30 some odd slides down to 2 with a lot of little stuff put in place. In that webinar, we covered designs of your typical, at least in this image right here, your US, Canadian, North American style distribution transformer, where you're looking at low voltage coils, high voltage, the low voltage foil windings, I'm sorry, high voltage copper conductors in many cases, the paper single phase in this particular example shown here. And then we highlighted some of the benefits of using DPE, diamond pattern enhanced papers, to show where you may get some additional benefits out of it. And this ties in nicely with what Brad was just talking about relating to thermal class and thermal index and the aging characteristics as the DPE product is allows you to get additional temperature profile or additional higher temperature class with the same size design in many cases, or using a smaller design, you can get the same output as well. So again, encourage you to go look back at this. This is a condensed thing here, but what we're looking at is combining with the increase of renewables, increased electrification, there's significant benefit for your layer wound transformer designs to use this DPE material to either get better output out of the same size or to reduce the size of the transformer and have a smaller footprint. And with that, we're going to move on to Lukas and sustainability.
Great, thank you. So you can go to the next slide, and we will have the next 2 or 3 minutes talk about sustainability in transformer insulation. And next slide, please. So for us at Weidmann, sustainability covers not only one area. One slide back, please.
Yep, sure.
But actually is covering multiple areas. So on the one hand, we have, of course, the material that we produce and manufacture ourselves. On the other hand, we have the life cycle assessment of the whole product and materials that reach us. And in the end, also the regulation and specifications that are applied to these materials. And to really be able to make change in this environment, we need to have, of course, a good communication with all the participants before us and after us. And so if we look, for example, in the material range, we can see that in our playground, we can change maybe the amount of recycled fibers or the materials we use to laminate our board and make it more sustainable. However, we need to know, of course, how can we align this with your needs and our needs. And also for life cycle assessments, for example, we need to be able to communicate with our partners the direct numbers to then also be able to assess this and optimize it in a way. So this is for us really a thing that we say we need to now in this changing energy sector make good communications possible with each other to really advance in a sustainable manner. And for us, coming to the next slide, we have, of course, a good stand here because in general, we use very sustainable materials. So we use the most abundant polymer on Earth, which is cellulose. we use water, which is also reusable, and of course, electricity. And so for us, it's not the question whether we want to use sustainable raw materials, but how to use them responsibly. So how can we really certify any pulp that comes into our site being FSC certified? Or what is the degree of recycling that we can do with our fibers to really maximize this process? And of course, with the water that we use for our process, we always are keen to not use any additives to make sure that the water we use can also be released back to nature and doesn't do any harm. And with the changing sector of renewables, we of course want to maximize our energy usage to a sustainable performance. We need to sometimes change something, but we are on track to become more and more a user of sustainable energy as good as this is possible. So these are the aspects that I wanted to highlight to you. Really, communication between partners to be able to make efforts and progress in a sustainable direction, enhancing the green energy transition, but to always also to look within and see where can I optimize my use of raw materials or electricity to not only make the product sustainable, but the whole process. And with this, I give back my speaking.
Okay. Frankie?
Okay, everybody. Thank you very much for the quick summary there. And just to reiterate, you can ask the questions as is shown on screen now. And in addition to what you've just heard from our colleagues, you can ask any question today. This is any question that relates hopefully to transformer insulation.
Thank you.
But I just wanted to point out that you don't have to only ask questions on the topics that you just heard. And I already see a number of questions bouncing in, and I will get to those. But I do have a couple of questions I'd like to get answered first. We have a question as related to a previous webinar from a client in Germany, in Deutschland, and the question was, what portion of our business is designing insulation structures for clients versus providing insulation pieces based on client drawings? So I guess maybe Balz as a designer would be able to, or as a lead in that department for Weidmann would be able to answer that one. What percentage or what portion of our business is designing insulation structures for clients versus using client drawings? Balz, over to you.
Weidmann has. Okay, thank you, Frankie. So Weidmann has design and engineering teams in the Americas, in Europe, and in Asia Pacific for developing insulation components. This is the main task of these teams. But these teams have the capacity not only for insulation components made of pressboard, they also offer a wide variety of additional consulting services like electromagnetic calculation, thermal calculation, design reviews, factory acceptance tests, failure investigations, and more. Part of the teams deal as well with the drawings provided by customers. So I would say the share is most about 80% components developed by Weidmann, 20% drawings coming from customers. Thank you.
Thank you very much, Balz. And just to tick off a couple of these questions that came in previously before we move to your many questions that are piling in my chat box here. A question from an R&D electrical engineer in Brazil. How is the water diffusion behavior in the paper oil insulation since ambient temperatures to higher temperatures, 80 degrees C? So how to test moisture content in this media? How would you test that? Brad, maybe that's.
Sure.
question for our lab guy.
Yeah, sure. Thank you, Frankie. So when we talk about moisture diffusion, absorption, desorption, so in general, as your temperature increases, that those changes occur faster. There are a set of curves, and I can't recall the name or who authored them, that give these relationships to show that how, as temperature increases, those absorption rates change. So we would have to look those up to look for a specific example. And then considering how to measure moisture in these changes, the best method for measuring moisture content, specifically when we talk about oil-filled or oil-impregnated samples, is using Karl Fischer titration. So having samples throughout the process, if you want to see how moisture changes, and taking those samples, sending them to a lab, and having that moisture content measured using Karl Fischer titration.
Okay, thank you. I'm going to take a question from the audience from Eton. And please excuse my pronunciation here, but will paraffinic or naphthenic oil, maybe that's not quite right, but we'll see, have an impact on thermal class of paper? Does anybody want to take that one? So paraffinic or naphthenic oil have impact on thermal class of paper?
I'll jump in really quickly here and say they're both types, standard normal types of mineral oils used in transformers. I do not believe that there is any thermal difference between the two, but I will let the lab guys correct me if I'm incorrect on that.
Yeah, I'll go ahead with that as well, Jason. As you said, both naphthenic and paraffinic oils will fit into the standard types of oil. And from our experience in various tests that we've done, they do not show a difference or a significant impact on the thermal class of those insulating systems.
Mm-hmm.
Okay, thank you. Another question from the audience, maybe relating a little bit to the services we provide. So a customer has been using DPE material and would specifically like a specification around permittivity and dielectric strength parameters, which they consider essential for conducting FEA electrostatics simulations to optimize design. They've been told to get in touch with Weidmann's optimization simulation services, which I believe is part of Jason and Balz's domains. What sort of support can we provide there, and how do you proceed with that type of project to get that simulation?
Okay. Balz, if you don't mind, I'll hop in real quick here on this and let you finish. It's part of our standard offering. Typically, when people think of using dielectric studies to optimize their clearances and solid and liquid insulation designs, you'd think it'd be a one-off type trial. Now with DPE, it's a little different because what you're trying to do is maximize savings and optimize designs for both quality, cost savings, efficiency of production on a product line as opposed to a one-off particular design. So it's a little bit more than just saying you need dielectric permittivity or your relative permittivity and then do the analysis. It gets into some more detailed studies that would be a real project with both companies, us and whomever it is that would want to be working with us on that. Balz, anything to add?
Nothing to add. That's it. We provide this information as studies, what we are used to do on our daily basis. So absolutely what Jason highlighted.
Thanks.
Thank you.
Okay. Thank you. I have a question from the very famous and frequent question provider, Mr. Krauser. formerly of Weidmann. He references a specific slide. So Jason, you may need to be
I'm
you
ready.
may need to be ready to adjust. So slide 4,
Okay.
bottom left. So if you can get back to that one.
Right. Is it showing on the screen?
Yep.
Okay.
The question from Christoph is, were these 3 different spacer thicknesses? And there was a follow-up to that that says the numbers shown are relative permittivity in brackets epsilon r. I'm not entirely sure how to translate that question, but I'm hoping that you understand the question. So was it different
So
spacer thicknesses and the numbers shown are relative permittivity?
yeah, I can answer this question here. So the charts in the bottom left, the compressibility, those are 3 different spacer thicknesses that you see, both milled and the unmilled surfaces. And one of the things trying to highlight here is that um, by milling off the surface, you have much more consistency in your compressibility and the reversible than when, and very little change between the two compared to the unmilled or leaving that screen pattern intact surfaces. You can see 1.5 millimeter unmilled is widely different than the 3 millimeter unmilled. So
Is it
by
safe to say that this is 1.5, 2, and 3 millimeter, Brad?
correct,
Okay,
yes.
thank you.
So that is the spacer thickness. Really just, again, just to highlight, by removing that screen pattern, we can have much more consistency in the products.
Okay, and then
Okay.
Frankie, the second one was, I apologize, could you repeat the epsilon portion of that?
Yeah, slide 5. The numbers shown are relative permittivity in brackets epsilon r.
Hmm.
Is that
Correct.
right?
And for what it's worth, this is what we're looking at here, the various relative permittivities, epsilon of mineral oil, 2.2 in both cases. And then what we were showing in this previous presentation was really the best way to utilize high density and low density materials to get a more optimized dielectric design. So what you're showing here is high density press board in mineral oil versus low density press board in mineral oil. So the epsilon values that we use typically for those are shown in each of these different boxes. Do you think that answered the question?
Not sure, but I have a feeling the browser will let me know. So just to move on there, I would like to ask another question about DPE.
Mhm.
So how does DPE impregnates or dries? How does it dry up to 30% faster when resin material acts as additional layer? Was the question. So how does DPE impregnate or dry up to 30% faster when resin material acts as an additional layer? Can somebody shed some light on that one, please?
Yeah, so first, talking about the resin, I mean, I would say that we are comparing um, DPE or this epoxy coated paper DPE compared to DPP. So we have the same epoxy layer in both samples. So any impact that that layer would have, we'll have it on both. So we can kind of we can say that, yeah, maybe perhaps it plays a role. However, uh, it would play a role in both standard Kraft paper as well as the DPE paper.
Right. And I would, to add on to what Brad just said there, um, it's not a full surface coating of the resin. It's that diamond pattern that goes on, which additionally provides a small channel for the insulating liquid to go through. So most of your liquid impregnation into DPP or DPE goes from the bottom or top in. So if you had a sheet. I hope this shows up with the filtering of the background behind me. But if you have a sheet of paper in front of you, it doesn't necessarily go in this way from an impregnation standpoint. It goes in, if you think of the transformer itself, from the bottom up through, and that those diamond patterns are on each surface. So it really shouldn't seal and impregnate or seal and prevent liquid impregnation if that's the concern.
Okay, thank you, Brad and Jason. Sticking with DPE, we have a question from Virginia Transformer in the US. Any expected variations on DGAs or furan levels derived from using DPE paper?
That is a good question. Brad, lab guy, or Lucas?
Yeah, I'm not aware. I'm not sure of the answer to that. I'm not in the oil testing labs or that realm as much, so unfortunately I don't know the answer to that. Something we'll have to follow up unless somebody else here has a response.
Yeah,
Okay,
that
well,
was a good question. We can certainly look into something, but I don't have a defined answer at this time.
okay, no problem. Thanks, and yeah, goes to show we can't answer everything there, which is good.
We'll
Something to look
put a
into.
pin in it and we'll loop back.
Yeah, a question here from a customer from Essex in Italy. Interested to understand more how the power transformer designers make the decision about which type of paper is needed. And yeah, I'll hand that over to you guys. How do power transformer designers make the decision about which type of paper is needed?
Balz?
So here we often deal with these design rules and make a decision depending on the temperature in the transformer and the field stresses around the copper, thermal issues, so that the oil circulating can cool the material. I think this is what we take for this subject. Maybe Jason, you have something else to add?
Not too much else. In some cases, the power transformer designers will be uh, limited based upon what standards or requirements may be from the end user, whomever is purchasing the transformer. So in some cases, it's the designer is not allowed to make any sort of real changes. If it's a 65 degrees C rise power transformer, then they must use a thermally upgraded paper in contact with the conductors. If it's limited to a 55 degrees C rise, then it's limited, then you would use a non-thermally upgraded paper. There are some standards available, both in IEEE and IEC, showing different, what's the word? Tables showing what different thermal classes of transformers are, depending on the combination of solid and liquid insulation type that would be used. So I think that may answer the question. I hope it does.
Okay, well, let's hope so. Let me have a look here. We have a question. Do we have some kind of algorithm or calculation for the dependence of water content in different types of insulation? And then it goes on to say in air humidity and temperature. So do we have an algorithm for the water content in different types of insulation?
I'm going to say an algorithm, no, but we have some thoughts, or we know that moisture content will affect, or humidity levels will affect the insulation. With cellulose specifically, at elevated humidity levels, we're going to absorb more water, and that will ultimately affect the properties of the material. Unfortunately, I don't have those answers off the top of my head. I believe we do have some history with that. Again, not knowing details, but if we look in our transformer board books, specifically transformer board 3, if you have access to that, I believe there is some information discussing how moisture will affect specific dielectric properties on the material.
Okay, thank you. Question here maybe for Balz from Siemens Energy. Do we or have we any experience either developing or working with enameled insulation of conductors and metal parts? Have we done any studies from a design perspective which aim to decrease the voltage distance between winding and surrounding metal parts using development of enameled insulation? Have we any experience there?
It's an interesting question. We haven't made any investigation in this respect, but yeah, we can take this input with us, which is really interesting and important, I think.
Okay, thanks, Balz. Well, we can provide the contact details afterwards for that follow-up, because that is an interesting question. Couple of quick questions on DPE, which keep coming in, different questions here. So the resin thickness in DPE should be 10 microns in one side. Does the increase in resin thickness cause any sticking issues?
No, I don't believe it does. I'm trying to think of what the issues could be, but honestly, off the top of my head, no. It's a standard, just like all our DPP product and most other products provided by competitors would be a standard B stage epoxy. And once you heat it up to a certain temperature during dry out and processing, it liquefies enough. Once it cools down, it then bonds and adheres to create a fairly strong bond. I've torn, and I know Balz has also done this. We've torn apart quite a few very old transformers over the years, and I can say that the DPP, or the diamond pattern printing or circular printing, whatever it may be, rarely bleeds and leaches in a very large pattern. It doesn't have a strong soaking into the material itself, if that's what was questioning. Balz, any thoughts on just in general the B stage epoxy diamond pattern printing?
Yeah, in general, it's what you said, Jason. Important is that the curing is done pretty well. Then it sticks quite good, but it's not completely closing everything. Yeah.
Well, and I'm glad you brought up B stage, because we've got quite a specific question here. So
Okay.
what, relating to DPE, so at what temperature does the resin change from B stage to C stage in DPE paper? I'm not sure if you have that number on the top of your head, Jason.
Gosh.
We can always
Brad?
come to that one.
That I don't know off the top of my head. I apologize.
Yeah, again, I don't have that off the top of my head. I know we have recommended time and temperature relationships, that when performing the curing process or the baking process of any coated paper, whether it's DPE or DPP, we can provide those time and temperature again recommendations. This is what we should use to achieve proper bonding within your coil. So if who's asking this question could reach out directly, we can provide that information for you.
And I guess as well, Brad, there's impact on the equipment that you're using to dry the transformer as well there. That's my
Yes,
technical
agreed.
contribution to this webinar.
And
Um, yep, go ahead, Brad.
I was just going to say, I believe we had shared those. That same question was asked in the prior webinar on this topic, and those curing recommendations and bond curves are posted along with the link to this previous webinar on DPE and renewables.
Okay, and just for everyone's information there, because I've had a couple of people ask me about access to the longer webinars and more information. We will at the end share with you the links to all our previous webinars in full so that you can revisit those and download the materials that Brad referenced there. And just one additional question on, I guess, the use of DPE, but also, for example, thermally upgraded and aramid fiber-based, typically Nomex material. Do we recommend to use such papers in the hotspot areas in the transformer? Is the question from Prolec.
That's an interesting question. It would require some so if we're talking a power transformer and typical hotspots where you'd see on one of the inner windings, usually a low voltage coil, somewhere roughly a third of the way down from the top of the coil, or quarter of a way, 10% down, somewhere in that range is usually where the estimated hotspot is. And it would be that would be an interesting, you'd either have to do all of the conductors wrapped in a much hotter or higher thermal class paper or insulating material, or you would have to get very specific about the distance along each spool that is provided for where they would make the changeover. Because what you wouldn't want to have is, let's say you're using a thermally upgraded Kraft paper, and then add additional wraps of a higher temperature rated insulating paper, whether that's a DPE or a Nomex brand or something else, because it wouldn't be in direct contact with the conductor. So you'd have to remove the paper that's on the conductor and then put the higher thermal class rating on. So I don't know if it's practical from a manufacturability standpoint. Balz, thoughts on this?
Yeah, I mean, I would just like to add to that, Jason. When we talk about the use of higher rated or higher thermal class materials or insulating systems, there are some documents within the standards organizations to kind of refer to. So specifically in IEEE, there is C57.154 when we talk about the use of higher insulating system materials. And then also standard 1276 in IEEE. And then when we consider the IEC, I believe the IEC standard is 60076-14 that talks about the use of alternative insulating systems or higher temperature insulating systems. So when considering or when discussing using these other materials, these standards are always a good reference to go review and understand before you do that.
Okay, thank you. And just to prove that we don't only ask the nice questions and ignore the rest, I have a customer here who is a conductor manufacturer who has been using DPE on aluminium and copper wires to wrap it, and they've been having breakages that have disrupted their production. So the question is, do we have any comment on why that material might be, why DPE on conductors might be breaking?
That's another good question. And thank you, Frankie, for throwing a mean one at us. No, in all seriousness, though, typically what you would need for a conductor wrap, it's not just taking flat sheets of a Kraft-based paper or Kraft processed paper, I mean. It's calendared craped in both directions, both length and widthwise, and then calendared to a uniform thickness. So it has a lot of good extensibility in each direction that you would want so that it wraps better and tighter. I am not certain that what is being used may be calendared appropriately for conductor wrap.
Okay, thank you. Okay, well, I guess that customer can get in touch with us for more
Absolutely,
information
yes.
on what's available there. Going back to the live questions, as we have lots covered in. We have a customer here from Hitachi who wants to know if we have an opinion on drying transformer insulation from 110 degree to 130 degree in vapor phase. Is there an opinion on those two different temperatures there? And do we have a recommendation, I guess, is the question. I know drying is always a tough topic.
Yeah, when we talk about drying of large power transformers, there's always um, obviously that's a bottleneck in OEM's facilities. We want to do it as fast as possible, but we also want to be kind of as gentle as possible. If we try to remove too much water too fast, there could cause other concerns or other damages to the material. So we do have some recommendations on limiting the temperature during kind of the first steps in the vapor phase process, and then to remove the bulk of the water from the insulation, and then increasing temperature from there. Um, so I don't have a specific answer on 110 versus 130, just that we want to kind of start gentle and to remove the water and then increase our temperature. Um, but then also considering that we want to, temperature is going to play a role, or increased temperature is going to play a role in uh, reducing the degree of polymerization of the insulation. So we want to also consider that and not increasing the temperature too high, um, even at the end. So again, kind of gentle in the beginning, um, less than 100 degrees C in the beginning. 90 is a recommended first step temperature for that kind of initial removing of the water, and then increasing from there.
Okay, thank you very much. A question from Brazil on paper and ester oil impregnation. Do we have any experience when using this combination about the behavior of paper during the dielectric stresses? Do we have any additional recommendations of care that should be taken when using ester oil rather than mineral oil with our paper products?
I'll let Balz kind of jump in first if you want, but if not, I can.
Please, Jason, jump in.
Okay. Um, Weidmann have developed curves using the ester liquids with a number of different solid insulation materials, including our products and others. Um, there are certainly considerations that need to be made with when using an ester versus a mineral oil with the products. Generally speaking, from a relative permittivity standpoint, they're a little closer together, so you get a bit more uniform distribution of the dielectric stress between solid and liquid. But you also need to consider um, the I always struggle with the proper phrasing of this, so bear with me for a moment, please. When you have an ester liquid versus a mineral oil, there is generally a higher latent moisture content in the liquid itself. That's just the physical properties of the materials. There, so what that means is it can, in the wrong circumstances, lead to a quicker propagation of a failure path. So once partial discharge has been initiated and in the proper sequence of uninsulated uninsulated electrodes, whether that's conductor, part of the active part, or a tank wall, something of that nature, if it's uninsulated and you have a large enough oil gap with a high, and you've initiated partial discharge with an ester liquid, it is slightly more prone to a full propagation of failure. So that's one thing to consider with those designs is more insulation, solid insulation, excuse me, generally means a safer design.
Yeah, Frank, before you jump back, I'd like to comment on I believe part of the question was about oil impregnation or rate when
Oh,
using ester liquids. So so ester liquids do have a higher viscosity than mineral oil. So in general, they will impregnate slower and take longer to be fully impregnated than the same design, same material than when using mineral oil. So that certainly needs to be a factor or a consideration when you're using esters. One thing that we have observed and tested with specifically the DPE is that the 30% increase or decrease in impregnation time is independent of liquid. So that improvement is seen both in mineral oil and in ester liquids. So when you consider that ester liquids will take longer to impregnate, but you can counter that at least partially by using DPE to increase that impregnation speed.
Okay. Thanks, Brad. And just a quick thank you and note from Diego Robolino from IEEE member and Mega. He mentioned that earlier there was a question on the effect of moisture and methods of detection in solid insulation. And he points out that for those using IEEE was consolidated in IEEE C57.162. So that's C57.162, where you can look at the effect of moisture.
just barely completed too.
Yeah,
It's brand
yeah.
new.
Well, thank you, Diego, for bringing that to our attention. I have another DPE versus DPP curing question. Lots of questions on DPE. Is there any difference between those two products for curing if there is oxygen available, or if we are under vacuum condition? Or in other words, needs the curing be finished before going into the vacuum cycle? So does the curing need to be completed before going into vacuum cycle? And is there any difference between DPE and DPP?
So I can answer the first portion of that easily, is that the epoxy used is the same for both DPP and DPE. So that is easy. Regarding the other question on vacuum or oxygen, I do not have an answer. I don't know if somebody else here does.
I don't think it would. I mean, off the top of my head and spitballing, I don't believe it would make some sort of difference, but I don't have a definitive answer. I don't mind following up on that afterwards if we have contact information, though.
Yep, we certainly do there. Quick question that I can answer just to shock all of you. We had a question, Lukas, I think you may tell me otherwise, but someone asked, what is the share of green energy that Weidmann uses for the production of board, and can this be improved? And I mean, I would answer that, and then I'll let Lukas chime in. We are now undergoing or taking part in the EcoVadis assessment of our business, and we have been for the last 2 years and seen significant improvements there. And we are conducting LCA, so life cycle assessments of our different products and production methods to be able to actually look at how overall we improve the green credentials of Weidmann as a whole, and not specifically in one particular area. But I will let Lukas add to that if you'd like.
Thanks, Francis. So in general, I would say there is one part that is a little bit tricky so far. We use in Rapperswil, for example, electricity and some natural gas. And all the natural gas we use is for the board presses. And so there is 2 ways that we need to go further in this topic. One is, of course, that we use the electricity that we get, that this is kind of certified green, sustainable, renewable energy and not coming from a coal plant. This is on the one hand, which we can kind of argue with our suppliers. On the other hand, it's of course also some infrastructure that we need to change to go away from the natural gas as a heating mechanism for the board. So yes, there is not 100% sustainable energy. We have a mix between natural gas and electricity. We looked at the electricity comes more and more from renewable energy sources, and we are looking into what are the mechanisms that we can do maybe to really get rid of the natural gas for all.
Okay, and I have a follow-up question on sustainability as well. Asking, do we use recycled material in our insulation products today, or in the production of our insulation products, I guess, would be the question.
So for now, there is a small percentage that we use in-house, of course, where we can get the cutoffs from our board and some also from the lamination board production to really be recycled and reused. As soon as we step outside of the boundaries of our production itself, we of course need to be very careful that we obtain good quality of offcuts from our customers. So there are considerations going on how much we can use on the one hand side, and on the more prominent side, really, how can we make sure that the quality of offcuts that we get from our customers are really such that we can again use it without any risk to the customers than when using the recycled one, of course. So yes, there is already some inside, but this is in-house, and we are now looking at what other sources of materials can we use for recycled board.
Okay, thank you. And as we only have a couple of minutes left, I wanted to try and just have try and get through a few of the quicker questions. Again, I apologize that if we didn't get to your question, and I also have 6 pages here of questions that we're still not getting round to. But quick question from Chevron. Is thermally upgraded paper more or less standard now for power transformers?
I think that depends entirely upon which region of the world you are in. It has been a standard in North America since the 1960s, the early 1960s, really with the introduction of Westinghouse. Around the rest of the world, it has been a little bit slower to be implemented in the design for power transformers specifically, and it's largely related to standards, which standard organization you choose to follow, IEC, IEEE, the various other types that may be out there, but I'd say it depends entirely on where you live.
Okay, thank you. Another quick question regarding DPE. We mentioned the customer asked about conductor wrap using DPE for that. Is our primary focus on that material layer insulation, or would we have a suggestion for using DPE for conductor wrap, or do we look to develop something specifically for conductors in that area?
I'll answer the first part of that anyways. It was developed with the primary focus being on layer insulation. And as we mentioned on one of the previous questions, it's really a true study where you're looking at efficiency from a processing standpoint, reducing dielectric clearances if possible, and then thermal class upgrading. So one of the big benefits of using DPE for layer wound is it can allow for quicker dry out, which improves the number of units you can get out the door or reduces the drying time for an OEM, which ultimately saves energy or allows them to get more units out. So that benefit is much reduced if it's just a couple layers on a piece of conductor, as opposed to many layers between the high-low gaps in a distribution style or layer wound style transformer. So it's typically used for layer wound due to all 3 benefits being achieved.
Okay, thank you. One very final question, Brad, from Doble. What method could be best used to measure heat in various parts of a power transformer and to aggregate the measurement results? Very quickly, Brad, please.
Yeah, so the only the best method for doing inside of an online or an energized unit would be using fiber optic probes. So embedding fiber optic sensors in various parts of windings or wherever you're interested, and getting the measurements from that.
Okay, thank you very much. Well, that brings to the end our live panel discussion, our review of the different webinars that we conducted throughout the year. We will be back in the new year. We will have a special edition early in the new year with Thomas Prevost, the IEEE Fellow Award receiver and medallion receiver, and maybe we'll get him to wear his medallion for the webinar. So we wish you all a fantastic end of the year. We thank you. We've had hundreds of people today join us and over the last webinars throughout the year. So we really hope that we can continue to support you and engage you with interesting content in 2025. Enjoy the holiday season, and we look forward to seeing you next year. And again, we will distribute the links to be able to review the previous webinars from 2024. If you have any questions, please feel free to reach out to us. We will do our best to answer them. I know we said that at the start of today's session, but we didn't get through all the questions, but we're here to help you. And yeah, thanks very much again. Stay safe, and we look forward to seeing you all next year in 2025. Thanks very much, and
Thank you all.
have a great rest of your day wherever you are in the world. Bye-bye.